Hello everyone, welcome back to my channel. I am Ranjit JS, a CST student from Sri Venkateswara College of Engineering, Bengaluru, and currently I am studying in third semester. And now in this video I am going to discuss a topic which is related to data structures, and the subject code is BCS304, and the topic is linked lists. Let us see the introduction to linked lists. A linked list is a linear data structure where elements are linked using pointers or references. Unlike arrays, linked list elements are not stored at contiguous memory locations, making them dynamic in size and efficient for insertions and deletions. Now let us see the definition and characteristics of linked list. Dynamic memory allocation. Linked lists enable dynamic memory allocation, allowing for efficient memory usage and allocation. Flexibility. They offer flexibility in terms of size and memory utilization, making them suitable for various applications. Complex operations. Linked lists facilitate complex operations such as reordering elements without any shifting. Now let us see the types of linked lists. There are three types of linked lists. First one, singly linked list. Second one, doubly linked list. Third one, circular linked list. First one, singly linked list. A type of linked list where each node points to the next node in the sequence. Doubly linked list. Each node has two pointers, one pointing to the next node and another pointing to the previous node. Circular linked list. The last node of the list points to the first node, forming a circular structure. Let us see the types of linked lists in detail. A linked list is a linear data structure where elements are stored in separate memory blocks called nodes. Each node contains data and reference, or it's also called as a link, to the next node in the list. There are several types of linked lists, each with its own characteristics and applications. First one, singly linked list. In a singly linked list, each node has a reference to the next node, forming a unidirectional chain. Singly linked lists are commonly used for dynamic memory allocation and applications where forward transversal is sufficient. As shown in the figure, there are four nodes which contain data field and the next or the link field. That is, A, B, C, D is the data which is present in the nodes, and each node's next or link is connected to the next node's data. Second one is doubly linked list. In a doubly linked list, each node has connected or linked to the both previous and next nodes, forming a bidirectional chain. Doubly linked lists enable backward traversal and are useful in applications requiring efficient insertion and deletion at both ends. As shown in the figure, there are four nodes in the linked list which contains two link areas, and node 1's left link is null and the right link is connected to the next node's left link, and this type of linking is done throughout the linked list. A doubly linked list is like a singly linked list, only it has the previous pointer. The last element tail will have the next property pointing to null. Third one is circular linked list. In a circular linked list, the last node points back to the first node, creating a circular structure. Circular linked lists are suitable for applications where continuous and rotation or looping is required. As shown in the figure, there are three nodes in the figure, and each node contains the data field and the next field, and each node's next field is connected to the next node's data field. At the same time, the last node's next field is connected to the first node's data field. Now let us see the conclusion of these types of linked lists. Linked lists are versatile data structures offering various types to suit different requirements. Understanding the characteristics and applications of each type is crucial for building efficient algorithms. Choose the appropriate type of linked list based on the specific needs for your applications. Now let us see the operations on the linked lists. First one, insertion. Adding new element into the list at the specific position or at the end or at the front. Second one, deletion. Removing elements from the linked lists based on a specific position or a value. Traversal. Accessing and processing each element in the list sequentially. First one, traversing a linked list. To traverse a linked list, start from the head node and keep moving to the next node until reaching the end of the list. In order to traverse a linked list, we should follow the following steps. First one, initialize a pointer PTR to the head of the linked list. And by using a while loop, while temp is not null, perform the following operations. First one, access the data stored in the current node pointed to by temp. Move temp to the next node in the linked list and exit. And the below is the example for traversing a linked list. Inserting a node at the beginning. To insert a node at the beginning of a linked list, create a new node with the desired data. Update the new node's next pointer to point to the current head node. Update the head pointer to point to the new node. The example code is in the image which is present at the right side. Inserting a node at the end. To insert a node at the end of the linked list, create a new node with a desired data. Traverse the linked list until reaching the last node. Update the last node's next pointer to point to the new node. In order to insert at the last, first we should create a new node with a given data. If the linked list is empty, make the new node at the head and return. Traverse the linked list till the last node. Change the next pointer of the last node to point to the new node. And below is the example code. Inserting a node at a specific position. To insert a node at a specific position in a linked list, create a new node with a desired data. Traverse the linked list until reaching the node before the desired position. Update the new node's next pointer to point to the node at the desired position. And here is the example code for insertion of any elements or nodes at specific position. Deleting a node from the beginning. To delete a node from the beginning of a linked list, update the head pointer to point to the next node. In order to delete at the beginning, create a temporary pointer temp and set it to the head of a linked list. If the linked list is empty, return. Set the head of the linked list to the next node. Free the memory allocated to the node pointed by the temp. And below is the example code for deleting at the beginning of the linked list. Deleting a node from the end. To delete a node from the end of a linked list, traverse the linked list until reaching the second to last node. Update the second to last node's next pointer to null. Example, deleting the last node from a linked list with a value 5, 10, 15, 20. In order to delete at the end, first we should traverse the linked list till the second last node. Set the next pointer of a second last node to null. Free the memory allocated to the last node. And below is the example code to delete at an end. Deleting a node from a specific position. To delete a node from a specific position in a linked list, traverse the linked list until reaching the node before the desired position. Update the previous node's next pointer to point to the node after the desired position as shown in the figure. Now let us see the searching for a value in a linked list. To search for a value in a linked list, start from the head node and traverse the linked list until finding the desired value or reaching the end of the list. In order to search in a list, first we should initialize a pointer PTR to the head of the linked list. While pointer PTR is not null, perform the following operations. If the data stored in the current node pointed to by PTR matches the specific value, return the index of the current node. Move pointer PTR to the next node in the linked list. If the specific value is not found in the linked list, return -1. And below is the example code to search in a linked list. Now let us see the conclusion for the operations which we have done on the linked lists. Linked lists are versatile data structures for storing and manipulating the data. Understanding the basic operations on linked lists is fundamental in computer science. Practice and implementation of linked lists operations will enhance your understanding of data structures and algorithms. Now let us see the advantages and disadvantages of linked lists. Advantages. This linked list uses dynamic allocation and dynamic size. It is easy to insert and delete in the linked lists. It uses efficient memory. Disadvantages. Random access is not possible. Additional memory for pointers is required. More complex operations cannot be run. Now let us see the comparison with other data structures like arrays, stacks, and queues. Arrays, static size, contiguous memory, random access. And the stacks, it follows LIFO structure, that is last in first out, limited access and the simple implementations. Queues, it follows FIFO structure, means first in first out, limited access, straightforward management, etc. Now let us see the applications of linked lists. It is used in music playlists, managing and organizing music track in media players and streaming services. Networking, representing a connection path between device in networking and data structures. Itinerary management, tracking and managing connections or routes in travel and logistics applications. Now let us see the conclusion of the video. Efficiency, efficient insertion, deletion and memory usage. The linked lists have a flexibility, flexible size, dynamic memory allocation, and diverse applications. Impact, significant impact on various fields from software development to network management. Thank you. Thank you for watching the video.